Good morning, folks. I'm going to try and keep this video shorter than the rest. I'm hearing in the background my son just woke up, so I'm going to try and get through this before he gets too cranky. What we see in front of us is the two solutions to the exit ticket from yesterday. I got a lot of questions on this. Number one issue I saw was with I forget which one of these was just the format of the Google form was submitting a number versus a text answer. I probably was this one then, the lower one. That was on me, my mistake. I did try to update the link and change the problem, so some of you caught that, some of you didn't. But it was all in the feedback, which was nice. Like I said earlier in the week, we are learning a lot this week, so we're going to hit little bumps along the way like we just did. Another couple of the comments were about the microphone on this. So the laptop I'm using right now is a loaner from the Tech Hub. There was an issue with my staff laptop. So unfortunately, the microphone this is a laptop that's a little bit older than the rest of the devices that teachers have. I can't do too much about that. It's not ideal. I will try to see if I can record on another device, but it's not going to be as easy with the platforms I'm using. So I'll do my best to just try and speak clearly and ignore the little, I don't even know if it's an echo or a warble or whatever the sound you're hearing is. So by now, hopefully you've hit pause and you can at least see the written out solutions. With the first expression, you're going to notice that the first term of the big expression is itself a formula. So I'm expanding it where one of my angles is x and the other angle is pi over 3. Separately, independently, I'm using a different formula for the second piece here, and that time the first angle is x, the second angle is pi over 6. So that splits it into 1, 2, 3, 4 products, each which has an x term and a known angle term. All 4 of those known angles we can simplify, and then you combine them all and they actually cancel, wow, to 0. Second expression, there's a couple different orders you could do operationally speaking. I'm going to distribute the 2 signs through these. That's where you see the first line. I'm rewriting cotan as cosine over sines with the appropriate variables. The signs all cancel out and you're left with a longer expression which combines down to cosine x plus y. 1 or 2 people talked about how canceling terms might lose solutions. We're not really solving an expression here or solving an equation here, so we're not really considered too much about the solutions here. However, it is an interesting point. This expression here does not have the same domain as this expression here, and that's because we're actually canceling out those signs. So if we were to truly call this equivalent to this, it would require a domain restriction, and the domain restriction would basically be anywhere the asymptotes of cotangents are, we would then restrict down here. Now, that's about all we need for section 10.1. I'm going to move on to 10.2, which is not really that crazy of a section. It's literally exactly the same questions, but now we're dealing with tangent. So what you see on the in front of you is the 2 formulas, one for when you're adding angles in tangent, the other is for when you subtract angles in tangent. Interestingly enough, and you can look this up in our textbook, these formulas are derived by simply taking the sine and cosine formulas and dividing them. So this is not like anything, it's not rocket science. You just took the tangent formula equals the sine formula divided by the cosine formula. So make sure you get these down in your reference. Again, these will be on a formula sheet as needed. Somebody asked, a couple people asked about calculators. I'm leaning toward any assessment would probably be a no calculator assessment. So just start practicing the expectation that a lot of this is coming from the unit circle or Pythagorean theorems, and that's about it. So tangent of 75 is going to be our first example, just to kind of see one quick run through. Again, we could do a lot of different angle combinations. So we can do 30 plus 45 degrees. We could do 135 minus 60 degrees. We could do 120 minus 45 degrees. There's really a few, lots of combinations. I'm going to focus on the top one, 30 and 45. I suspect that's what most people would choose anyway. So obviously then we have tan of 30 degrees plus 45 degrees equals, and I'm going to use my upper formula here, tan A plus tan B all over 1 minus tan A times tan B. So we have tan 30 plus tan 45 all over 1 minus tan 30 times tan 45. My son is downstairs screaming for me. Not screaming, but he's hearing me talk. So you might hear him in the background. Tan of 30 degrees is rad 3 over 3. Tan 45 is, of course, 1. 1 minus tan 33, or 30 is rad 3 over 3. Tan 45 is 1. There's that. Now, we have a value, but it's not a simplified value. There's a couple issues. We have fractions on the numerator and denominator. We have radicals in the denominator. So I'm going to just take care of each of those issues one at a time. So I'm going to start by simply multiplying through a 3 to both the numerator and denominator. And that's what's left. Still have the radical. So at this point, we're going to multiply through by a conjugate. So that's going to leave us with a, let's see if I can do this mental math here, 9 plus 6 rad 3 plus 3 over 9 minus 3. And then obviously the 9s and the 3s can combine, so we're going to have a 12 plus 6 rad 3 over 6. Everything then can reduce by a power of 6 or by a factor of 6. And we have a 2 plus rad 3. So the challenge here with tangent is not necessarily the trig part, it's a lot of steps of algebra that you have to very carefully simplify one aspect at a time. This would be your final simplified answer. Now, very quickly, we're going to do 2 more styles of questions that are fair game for you. So here we have an expression where it's simply simplified. So we have tangent of an angle plus tangent of a different angle over 1 minus the product of the tangents. So you're going to probably recognize that it is, I hope you guys can hear him. He's screaming for our dog Ollie right now. So combine these two together, you end up getting 2/3 pi is really 8/12 plus 1/12 is 9/12 pi, which is 3 pi over 4. Tangent of 3 pi over 4, -1. Okay, so all of that complicated mess simplifies quite a bit. Show. All right, so this is a proof. This is a verify statement. So we are going to show that this expression is the same as this expression. So really, we're not going to consider this equal sign because we are tasked with proving they are equal. So I'm going to focus just on this, and I'm going to manipulate the expression, and hopefully it matches this expression. That's the big strategy with a show, prove, verify type of task. So what I'm doing is I'm going to start with, I'm going to pause. I can't ignore a crying son. Okay, gave him a bottle. He's quiet. This is the joys of teaching from home with a 1-year-old. So tan, negative theta, or negative alpha. We're going to rewrite negative alpha as 0 minus alpha, and probably you can see where I'm going from here. So I'm going to use my subtraction formula where the two angles are 0 and alpha. So this expands to tangent 0 minus tan alpha all over 1 plus tan 0 tan alpha. Now, don't get too concerned about tan alpha on the bottom because we don't really know what that is, but we do know that tan 0 is 0. So that cancels, and this term cancels all of it because 0 times tan alpha is still 0. And we're left with negative tan alpha over 1, which is just negative tan alpha, and we're done. So take a look at the Google form. I'm going to also upload a worksheet of practice problems. So the Google form is likely going to reference 1 or 2 problems from that worksheet, and then the rest of that worksheet will be additional practice as you need it.